Hello guys and welcome back to my YouTube channel. In this video we are going to learn how to calculate median for grouped data without class intervals, and also I am going to explain how to write R code for this. So let's learn. In order to calculate median for ungrouped data, we will be using this particular data set. Ungrouped data without class intervals means nothing but data points will be given. That means X values are given and their respective frequencies are given here. For example, we can say that 1 is repeated 8 times, 2 is repeated 15 times, and so on. Our next step is to calculate total number of data points. Before we begin, we need to know how many data points are there. So we can calculate this by calculating the summation of this particular column, that is F column. This summation is denoted by capital N. Capital N is equals to summation of F. So summation of these four values, that is 8, 15, 12 and 5, that is equals to 40. Our next step is to calculate less than cumulative frequency. So I will write here less than cumulative frequency. We will be calculating this less than cumulative frequency in a new column. That these values we will be using for further calculations also. So less than cumulative frequency, we start with 8. We start with the first frequency from the frequency table. We can consider here 8 as it is, and next number will be equals to 8 plus 15, that is equals to 23. 15, 8 means previous less than cumulative frequency value, and 15 is the next 15 is the current frequency value, and the next less than cumulative frequency will be equals to 23 plus current frequency value, that is 12, which is equals to 35, and last frequency value is equals to previous less than cumulative frequency, that is 35, and current frequency value, that is 5, which is equals to 40. So in this way we can calculate less than cumulative frequencies for X points, or for the given data points. We can say this less than cumulative frequency value is the value that denotes us, or that tells us that how many data points lie below a given particular value. For example, we can consider that less than cumulative frequency of 1 is 8. That means there are total 8 data points which are less than or equal to 1. Next one is less than cumulative frequency of 2 is 23. That means total 23 data points are there which are less than or equal to 2. And in the same way, less than cumulative frequency of 3 is 35. That means total 35 data points are there which are less than or equal to 3. This less than cumulative frequency value is very helpful, or it's one of the application with which we are that's the reason we are using these values to calculate median. Now we are at the last stage of calculating median. We know that median is a point that divides data set into 2 points. Consider X is a median, so X will divide data set into two points. Below that X value, 50% of data points will lie, and above that X value 50% of data points will lie. Here it is given that here we have given that 40 data points are there. Total 40 data points are given. So 50% of the given data set means n by 2. N by 2 is equals to 40 by 2, that is equals to 20. That means we need to find out X value. Below that X value, 20 data points should be there. That means here it comes the application of less than cumulative frequency values. We need to find out the less than cumulative frequency which is immediate greater than or equal to this 20, this n by 2 threshold. Starting with 8 is not immediate greater than or equal to 20. Next 23, correct. 23 is immediate greater than or equal to 20, and the respective x value is 2. So our median is 2. So our answer median is equals to 2. Here we consider immediate greater than equal to 2, because for example if we consider 35 and the respective x value is 3. 3 will come somewhere here, which does not divide dataset into two parts. Median is value that should divide dataset into two parts, 50-50, but here we know that 3 there are 35 data points which are less than or equal to 3. That means below that 3, 35 data points are there, and above 5 are there. That does not divides the data set into two equal parts, but x value, that is 2, divides the data set into two equal parts, that is 2, that is 20 and 20. So final answer median is equals to 2. So in this way we can calculate median for grouped data without class intervals. Now we will write R code for this. First of all, we need to store given data. That means we need to store x and f values. I will store these x and f values in their respective vectors. X vector is equals to 1, 2, 3 and 4. In this way we will store x values. Next, f values is equals to f vector. Respective f values are 8, 15, 12 and 5. Our next step is to calculate the total number of data points in the given data. That means we need to calculate the summation of f. Summation of f we denote it by capital N. So I will initialize a variable with that stores value 0 in capital N itself. We have done this many times. We have calculated frequency many times. You guys can refer my previous videos for that. So for now I will write the final for loop for this. So for I in 1 to length of this f, and I will update this n value. So n is equals to previous n plus current f value, that is f of I. Outside the for loop I will print this n value. So let's run this program and let's check. And here it is, n is 40, that is total number of data points are 40. Our next step is to calculate less than cumulative frequency. So for that I will declare an empty vector. Name will be LCF itself. LCF is equals to empty vector. So as we have seen here as we have seen, first value of this LCF vector is the first frequency value itself. That means here as you can see that we are storing 8 as it is in the age 8, that is the first frequency value we are storing as it is as the first less than cumulative frequency value. The same thing we are doing in R also. So LCF of 1 is equals to f of 1. So here we can print LCF at this point and we can check. So here it is, LCF is storing 8 at this point of time. So we will update this LCF through for loop. For that I will, so this is our data set and LCF. We are LCF of 1 is f of 1, that this thing we have seen right now. So for this point of time LCF is storing 8. Next, LCF of 2, that should be equals to previous value of LCF, that is LCF of 1 plus current value of frequency, that is LCF, that is f of 2. So LCF of 1, that is previous value it was 8 plus current frequency value, that is equals to 15, that is equals to 23. At this point of time, LCF is storing 8 and 23, these two values. Again, we need to increase the I value, we need to go forward in our for loop, and LCF of 3, that is equals to previous LCF value, that is LCF of 2 plus current frequency value, that is f of 3. LCF of 2 is nothing but 23 plus current frequency value 12, that is equals to 35. At this point of time, LCF is storing three values, 8, 23 and 35. Now we are at the last stage of our iteration, that is LCF of 4 should store LCF of 3, that is previous LCF value plus current frequency value, that is f of 4, that is equals to 35 plus 5 and 40. Result is 40. At this point of time, we are done with our for loop, and LCF is fully updated and it is storing four values, 8, 23, 35 and 40. The same thing, this 4 step we have written. Actually these are 3 steps, LCF of 2, 3 and 4. These things we will put inside the for loop. So in VS Code, for loop will begin from 2, because we have already stored f of 1 at the first position of LCF of 1. So for loop will begin from 2 till the length of f. LCF of I is equals to LCF of I minus 1 plus LCF of I. We will print this LCF value outside the for loop. Here it is. LCF is storing all the 4 values. All the 4 are correct. 8, 23, 35 and 40. In this way, we can calculate LCF using for loop. Now that we have calculated the LCF values, our next step and final step is to calculate the median. Here I have written given data with their respective LCF values. Our next step and final step is to calculate the median. That means we need to find out the x value whose LCF is immediate greater than or equal to 20. That means, as we have calculated, our median is 2, because LCF value of 2 is immediate greater than or equal to 20, that is 23. We need to extract 2 from this table, from this information, using for loop. Now, for example, these are the I values. Everything is written in R. I have just written everything in tabular format. I values, that means indices will remain same. Indices will start from 1, 2, 3 and 4. Here I values, another separate column I have written just for our understanding purpose. LCF of I, for our for loop will begin. We know that our for loop will begin from 1, 2 and it will go until 4. When I will become 1, that is we are at the first step, we are at the first iteration of our for loop. With this we can access LCF of I, LCF of 1, f of 1 and x of 1. Here we need to check LCF of 1. Here LCF of 1 is 8, which is 8 is not greater than or equal to 20. So we will skip this. Next thing, I will become 2, that is we are at the second iteration of our loop. I will become 2 and LCF we got 23. LCF will got 23, which is immediate greater than or equal to 20, and we will extract the respective x value. That means x of 2, we need to extract x of 2 and store in the variable median. That median variable we will be declaring outside the for loop, and we need to store this x of 2, and we need to break the for loop immediately, because we don't want to update the median variable again and again. We at the second iteration we got LCF, which is immediate greater than or equal to 23, and we will break this for loop. So here I will write the for loop manually. Before starting with the for loop, I will declare a variable called as median outside the for loop, and I will store 0 in it. And for loop for I in 1 to length of f, and in that for loop, if we get LCF which is greater than or equal to n by 2, that is 20, we will store that I value, x of I value, that is median is equals to x of I, and we will immediately break the for loop. Break statement is required, and outside this for loop I will print this median variable. The same thing I will so in this way we can get our median, that is 2. I will write the same code I will write the same for loop in VS Code. So let's start here. Median is equals to 0, then for I in starting with 1 to length of f, if LCF of I greater than or equal to n by 2, median is equals to x of I, and break statement, and outside the for loop we'll print median. Let's run this code finally. Here it is, we got median is equals to 2. In this way we can calculate median for grouped data without class intervals, and this is the R code for it. Thank you.